So, dear students, in the last class we learned about the extractive metallurgy of aluminum and copper, right. So, today we are going to study the extractive metallurgy of iron. Iron is the second most abundant element found on earth crust. The first most abundant element found on earth crust is aluminum. Secondly, iron is the most abundantly found element on earth crust, right. So, first of all we should study the important ores of iron. Okay. Number one is hematite, that is Fe2O3, then magnetite Fe3O4, then the last one is what, iron pyrites FeS2, right. So, among these Fe2O3, hematite is the chief ore of iron. You know this is an oxide ore. So, the first step of any extractive metallurgy is concentration. Here also it goes. So, the concentration of the ore, here it is concentrated by gravity separation or hydraulic process. See, the ore is powdered well, then that is placed on the slopy, vibrating and corrugated table. Then this is washed away by means of jet flow of water. The light impurities are washed away and the heavier ore, that means hematite ore, that is retained on the table. Now we get, see, the ore is concentrated, that means now the ore is in its purest form, right. So, that is the first step. Second step is roasting and calcination. Here it is heated, that means at high temperature, that is heated, that is roasted well. The moisture content is driven off, that is vaporized, and the volatile impurities like what, arsenic, sulfur, antimony, these are oxidized. Then the third one is what, see here, smelting process, that means smelting is done in the blast furnace. Okay. See here, this roasted ore and coke and limestone in the ratio 8:4:1, that is introduced into the blast furnace. See here, see a fine structure is there, cup and cone arrangement at the top is there. Through that, that means this mixture ore, coke and this silicon, that is introduced through the cup and cone arrangement. Okay. See here, in this blast furnace there are three zones, there are three parts, three zones are there. The lowest is the combustion zone, middle is the what, see it is the fusion zone, and the upper portion is what, it is the reduction zone, right. In the lowest zone, that means in the combustion zone the temperature is 1500 degrees Celsius. In the middle zone the temperature prevails here is 1000 degrees Celsius. Okay. Then in the uppermost part, that means the reduction zone, the temperature is 400 degrees Celsius. Okay. So, now let us look what reactions goes on there in these three regions. Okay. The first, that means in the lowest portion the temperature is 1500 degrees Celsius. Here the carbon combines with oxygen and gives carbon dioxide, and enormous amount of heat is liberated. So, this is a exothermic reaction, right. So, carbon, that means coke mixed with the ore, that is converted into carbon dioxide at the bottom, okay, in the combustion zone. Then in the middle zone, that means in the fusion zone, the temperature, you know, there is 1000 degrees Celsius. That carbon dioxide combines with carbon, coke, and converted into carbon monoxide. Then already we added what, calcium carbonate, right. That calcium carbonate is decomposed into calcium oxide and carbon dioxide. Okay. This calcium oxide again combines with SiO2, that means silica, and calcium silicate CaSiO3 is removed as slag. Okay. Now you have what, carbon dioxide, right. This carbon dioxide again converted into carbon monoxide, right. Then in the upper zone, that means in the reduction zone, this carbon monoxide combines with Fe2O3 and gives iron and carbon dioxide, right. So, you get carbon. Now, this carbon, see, this is very spongy and this is called what, pig iron. This pig iron is cast into molds and this is called cast iron. Okay. So, this is what, how you convert your ore into iron. Okay. So, these are the processes, like that means see here once again, first step is concentration, and in the second process it is calcination and roasting. In the roasting step, what happens? The impurity like what the water and see the volatile impurities are driven off as their oxides. In the third step, it is smelting. That means this roasted ore that is mixed with coke and limestone in the ratio 8:4:1 is introduced into the blast furnace. Here there are 3 zones. The lower portion, that is the combustion zone, the temperature is 1500 degrees centigrade. Here carbon combines with oxygen and gives carbon dioxide. In the middle zone, carbon dioxide combines with carbon and gives carbon monoxide. Okay. The temperature here is 1000 degrees centigrade. In the upper region, that means it is a reduction zone where Fe2O3 it combines with carbon monoxide and gives you iron. So, this is what the metallurgical process of iron. Okay. Now, see we move on to the uses of iron. See here pig iron. What do you mean by pig iron? It contains 2 to 4.5% of carbon. This is used for making pipes, stoves, radiators, railings, manhole covers and drain pipes. So, these are made by this pig iron. Okay. Then steel, that means it is iron with less than 0.25% of carbon. You know the uses of steel. This is used for what? It is used widely used in buildings, machinery, cables, that means transmission cables, TV towers and what? Making alloys. So, these are the important uses of what? Steel. And finally, wrought iron. This is iron with 0.25% of carbon. Okay. This is used for making springs, anchors and electromagnet, right. Okay. Dear students, now we move on to the chemical properties of iron. Okay. See first one, reaction with air or oxygen. See on heating it becomes magnetic oxide. Magnetic oxide means Fe3O4, 3Fe plus 2O2, 3Fe plus 2O2 gives Fe3O4. It is the oxide, but it is a magnetic oxide. Fe3O4 is the magnetic oxide, it is black in color, right. Then reaction with the moisture. See, you know this reaction, this is a very well known reaction. Okay. This is known as a rusting, that means reaction of iron with moisture. When iron is exposed to moisture, it forms a layer of, that means a green colored, reddish green colored layer of iron oxide, ferric oxide, okay, hydrated ferric oxide. This chemical is known as a rust and the process is known as what? Rusting. Okay. The equation is 4Fe plus 3O2 plus XH2 gives 2Fe2O3 XH2. This is rust and the process is known as what? Rusting. Okay. See here, then a reaction with steam. When steam is passed over a red hot iron, magnetic oxide is formed. The equation is, that means steam is passed over red hot iron, it gives magnetic oxide. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Then it is a reaction with chlorine. Iron combines with chlorine and gives ferrichloride. 2Fe plus 3Cl2 gives 2FeCl3. Okay. So, these are the important reactions of what? Iron, and one more is there on reaction with acid. With dilute HCl and dilute H2SO4, it liberates hydrogen gas. Fe plus 2HCl gives FeCl2 plus hydrogen, that means hydrogen is liberated. Same way, iron combines with sulfuric acid. Fe plus H2SO4 gives FeSO4 and hydrogen gas is liberated. With dilute HNO3 and again in cold condition, dilute HNO3 in cold condition, it gives ferrous nitrate. 4Fe plus 10 HNO3 gives 4FeNO3 twice plus NH4NO3 plus 3H2, ferrous nitrate FeNO3 twice. It is the product formed here. With concentrated sulfuric acid, it forms ferric sulfate. 2Fe plus 6H2SO4 gives Fe2SO4 thrice plus 3SO2 plus 6H2. Sulfur dioxide gas is liberated here. But when you dip iron in concentrated nitric acid, see here, it becomes chemically passive, that means it is inert, because there is the formation of a layer of iron oxide Fe3O4 on the surface of iron. Okay. So, these are about your iron. So, we studied the extractive metallurgy, its uses, chemical and physical properties. You know the physical properties, it is grayish white in color, it has luster, it is malleable, ductile, it is a good conductor of electricity. Okay. So, these are all about your iron. Okay. The next topic is alloys. What is alloy? Homogeneous mixture is a homogeneous mixture of two or more metals or one or more metals with non-metallic elements. Okay. So, this is called alloy. Then when you make an alloy, the properties of alloys are different from those of its constituent elements. For example, gold, it is too soft to be used, but when it is combined with a small percentage of copper, it increases its utility as well as its hardness. Okay. You know what amalgam is? See, amalgam is an alloy of mercury with other metals. Silver tin amalgam, that is used for dental filling, right. See here, then different types of alloys. See here, alloy is a solid solution. You know what solution is? Solution contains at least two elements, two components. One is solvent, other is solute. So, alloy which contains larger percentage of the component, that is called solvent, and which contains the lesser percentage is the solute. For example, brass. Brass is an alloy in which, see here, zinc in copper. Zinc is the smallest percentage, it is a solute, and copper is what? It is a solvent, right. What are the methods of making alloys? There are two methods. Number one is fusion. That means by fusing two metals, you will get alloy. The second method is, see here, see, you can compress the finely divided metals into alloy. For example, see, it is a wood metal that is formed by compressing tin, lead, bismuth and cadmium, right. See here, next we look on to what are the reasonings for making alloys. What are the reasonings? See here, first one, it modifies appearance and color. Single metal, its appearance and color is different from those of what is alloy. So, it modifies the appearance and color. It modifies the chemical activity. It lowers the temperature. See here, it increases the resistance to electricity. It increases the hardness and what utility. So, these are the reasonings for making alloys. You know, it is a solid solution. Okay. Now, see here, there are two different types of alloys. Number one is ferrous alloy and number two is non-ferrous. Ferrous alloy means it is an alloy in which iron is the major content. Okay. So, what is non-ferrous? It is an alloy which does not contain what? Iron. Okay. So, non-ferrous alloys, there are two types. One is copper alloy and the second one is what? Aluminum alloy. Okay. Copper alloy, see here, brass and bronze. Brass and bronze. Brass is an alloy of copper and zinc, and bronze is an alloy of what? Copper and tin. Okay. So, brass, see, it is used for making what? Electrical fittings, and see here, metals, decorative items. Okay. So, these can be made by means of what? Your brass. Then bronze, statues, coins, bells and gongs, this can be made by means of your bronze. Next, see here, aluminum alloy. Number one is, see here, duralumin, that means it is an alloy of aluminum, magnesium, manganese and copper. This is widely used for making aircraft parts and tools. Then pressure cooker. Okay. Then see here, duralumin, aluminum and magnesium, it is an alloy of aluminum and magnesium. This is also widely used for making what? Aircraft parts. Then see here, scientific instruments. Okay. See here, final one is alloy of iron, that means number one is stainless steel, is an alloy of iron, carbon, nickel and chromium. This is used for making cutlery. Then see here, utensils and automobile parts. Finally, nickel steel, iron, carbon and nickel, see here, this is also used for making automobile and aircraft parts. Then cables and propellers. Now, we move on to the next topic, that is corrosion. See here, you know what corrosion is. See here, it is a gradual destruction. It is the gradual destruction of the metals by chemical or electrochemical reaction with the environment. That means the metal surface that may be converted into oxide, sulphide or hydroxide, that means it loses its metallic character. Okay, that means it is gradually destroyed. The metal surface is gradually degraded, that is called corrosion. See, in the corrosion, you might have known this topic, that means rusting. See, when iron is exposed to moisture, what happens? It because see there will be the formation of a reddish brown layer on the surface of the iron, that means hydrated ferric oxide, Fe2O3 XH2O, iron plus water plus oxygen. It gives you Fe2O3 XH2O, that means hydrated ferric oxide on the surface of the iron metal, that is known as rusting, and that chemical is known as rust. Okay. See here, there are two types of corrosion. Number one is dry corrosion. It is otherwise known as chemical corrosion, dry corrosion. See, as the name suggests, it happened in the absence of what? Moisture. That means it is a chemical reaction. See here, the destructive gases like oxygen, nitrogen, hydrogen sulfide and sulfur dioxide, it acts on the surface of the metal and it makes it destruction. Okay. That is known as what? Dry corrosion. Here the metal surface is subjected to the chemical attack by this, and among these oxygen is highly destructive. The next one is what? Wet corrosion, or it is known as electrochemical corrosion. See, as the name suggests, it happens in the presence of moisture. Here electrochemical reaction of water or the aqueous solution of acids, bases or salt, that is the reason for the wet corrosion. Okay. See here, next we move on to the methods of preventing the corrosion. See here, see, metal can be prevented from the corrosion by means of two methods. Number one is alloying, that means metal can be alloyed, so as to prevent it from corrosion, and the second is surface coating. Under the surface coating, there are four methods. Number one is galvanization, that means coating of zinc over iron, that is known as galvanization, so that you can protect iron. Second one is electroplating, that means you can coat one metal over another metal by means of using electricity. That process is known as electroplating. So this method is widely used because it can be used to protect the metal. The third one is anodizing. Here it is the electrochemical process that converts the metal surface into corrosion resistant, durable and decorative, so that you can, that means anodizing means it is the coating of a metal over another metal. The coated material is the anode, and aluminum is widely used for anodizing. And the last one is cathodic protection. It is a method of controlling the corrosion of metal surface. Metal surface protected is coated with the metal which is easily corrodable. That means one sacrificial metal is there, that is coated on the metal, that is corroded easily, so that you can protect the metal. The protected metal is used as a cathode here. One fine example for this is Pamban bridge. It is a bridge that connects the important town of Rameswaram, that is Pamban, to the mainland of India. See here, it is protected by means of a periodic protective coating on this bridge, and it is one of the examples for applied chemistry. See here, now it is the evaluation part. The number of periods and groups in the periodic table are, here the number of periods and groups in the periodic table are, you know, it is 7 and 18. There are 7 periods and 18 groups, right. See, the second question, the basis of modern periodic law. The basis of modern periodic law is, you know, it is atomic number. Dash group contains the member of halogen family, you know, it is the 17th group, right. Fluorine, chlorine, bromine, iodine, acetylene, these are the members in halogen family. So it is the 17th group, right. Then dash is a relative periodic property. The relative periodic property is electronegativity. You know what the electronegativity is. You see, it is a relative tendency of atom in a molecule to attract the shared pair of electron towards its side. So this is called what? Electronegativity, and it is a relative periodic property. That means it can be related to other, right. Then dash propounded the modern periodic law. It is Henry Moseley. See, next question is state the modern periodic law. You know, the chemical and physical properties of elements are the periodic function of their atomic number? This is a very important question. See, it may ask in your public examination. State modern periodic law. See here, the chemical and physical properties of elements, these are the periodic function of their atomic numbers. The seventh one is, what are inner transition elements? See, you check your periodic table. In the third group, there is a part, that means lanthanides and actinides, that are actually the part of third group, but that is placed below the periodic table as a separate, a separate group. That lanthanides and actinides, these are altogether, that is known as what? Inner transition elements. Then define ionization energy. What is ionization energy? It is the minimum amount of energy required to remove an electron from neutral atom in its ground state. Okay. See here, in a ground state, there are some protons that attracts the same number of electrons, right. So, when you try to remove an electron from that atom, you should invest some amount of energy. So, the minimum amount of energy required to remove the outermost electron from a neutral atom in its ground state, that is known as ionization energy, and it is expressed in terms of kilojoule per mole, right. See here, next question, that is an important metal to form amalgam. Amalgam, you know, it is an alloy of mercury. Okay, and see here, the silver tin amalgam, that is used for dental filling. Then the next question, dash is the chief ore of aluminum. It is bauxite, Al2O3 2H2O, bauxite ore. It is the chief ore of aluminum. Then the next question, the chemical name of rust. The chemical name is hydrated ferric oxide, that means Fe2O3xH2O. Hydrated ferric oxide is the chemical name of rust. The next question, dash and dash are called inner transition elements. Yes, lanthanides and actinides are called inner transition elements. Then again the same question, dash is used as dental filling. Yes, silver tin amalgam. Okay. Then the next question, what are the different methods to concentrate the ore? You know, there are 4 methods. Gravity separation or the hydraulic method, magnetic separation, froth flotation process, and the leaching are the 4 methods of concentrating the ore. Then they mention 2 uses of copper. You know, uses of copper. See here, it is widely used for making electric cables, electric appliances, then making alloys. Then see, it is mixed with the gold and silver to make jewels. Okay, it is a good conductor of electricity. Then see here, what is an alloy? What are the different types of alloys? You know, alloy means, see, it is a homogeneous mixture of 2 or more metals or 1 or more metals with non-metallic elements, right. 2 different types of alloys are ferrous and non-ferrous, and in the non-ferrous, copper and aluminum alloys. Okay, these are there. Okay, dear students, so let us recapitulate what we studied from this lesson, periodic classification of elements, right. See here, what is modern periodic law? The chemical and physical properties of elements are the periodic function of their atomic numbers, right. Then what is modern periodic table? See, it is the tabular form of arrangement of elements in rows and columns, highlighting their repetition of properties, right. What are different periodic properties we studied in this lesson? Number 1 is atomic radius. You know, it is the distance between the center of the nucleus and the outermost orbit contain electron cloud. Okay, it is measured in angstrom. Okay, so that is atomic radius. What is ionic radius? What is ion? Ion is the charged particle. It may be positive or negative. Positive ion is called cation, negative ion is called anion. What is ionic radius? See, it is similar to your atomic radius. Here, it is a distance between the center of the nucleus and the outermost orbit contain electron cloud of ion, that is ionic radius. What is ionization energy? It is the minimum amount of energy required to remove an outermost electron from a neutral atom in its ground state, that is ionization energy. Since this is energy, it is measured in kilojoule per mole. Okay. Then electron affinity. See here, when you add electron to a neutral atom, some amount of energy is released. That much amount of energy is known as electron affinity. This is also energy. So, this is expressed in terms of kilojoule per mole. What is electron negativity? Electronegativity means it is a relative tendency of atom in a molecule. In a molecule, there may be at least 2 atoms. So, between these 2 atoms, one is having what more electronegativity. That means it has more power to withdraw the shared pair of electron towards that side. That property is known as electronegativity. Okay. See here, then we studied about metallurgy. What is metallurgy? See, it is the extraction of metal from the earth and modifying it into alloy for various purposes based on its physical chemical properties and the structural arrangement of the atoms, right. Then the important terminology we studied in metallurgy. Mining. What is mining? It is the extraction of the metal from the earth, right. What is mineral? Mineral means it is a single compound or it is a complex mixture of various compounds of a metal, that is called what mineral. Then what is ore? Ore means it is a mineral, but from that we can extract the metal in its profitable way, profitably, that means economically, that is called ore. For example, bauxite is a ore of aluminum, but clay is a mineral of aluminum, right. Then gangue or matrix. Gangue means it is a rocky impurity associated with ore, that is what gangue. Then see here flux. Flux means it is a substance, extraneous substance added to the metal in its metallurgical process to lower the fusion temperature as well as to remove the impurities. Okay. Then what is slag? Slag means see this flux reacts with the rocky impurities and it becomes a fusible product that can be removed, that is called what slag. Okay. So, these are the important terminology we studied in the case of metallurgy. See here, then some metallurgical process, that means metallurgy of aluminum, copper and iron. See, whatever may be your metal, there are some important steps. Number 1 is what? Concentration. So, depending upon the nature of the metal, different techniques can be used. In the case of aluminum, it is leaching. See, in the case of metallurgy of aluminum, there are 2 steps. Number 1 is what? Bayer's process. Number 2 is Hall's process. Okay, keep it in your mind. Then, for copper, it is concentrated by froth flotation process. It is roasted, then it is smelted in the blast furnace, and finally besmerization. Finally, you get blessed copper. And in the case of iron, see here, first it is concentrated by means of gravity separation, because it is an oxide ore. Then this is roasted and calcination. Here the impurities like what water and the volatile impurities are removed. Then blast furnace, smelting in blast furnace, finally you get iron. See, whatever may be your metal, finally at the end of the metallurgical process you get metal, but not in its purest form, that is to be refined. In most of the cases, electrical refining is used. So, anode, cathode and electrolyte are used. So, by using this technique you get the metal in its purest form. Okay. Then we studied what the important uses and the important chemical and physical properties of these elements. Okay. Finally, see alloy. What is alloy? Alloy means it is a homogeneous mixture of 2 or more metals or 1 or more metals with non-metallic elements. And see here one of the important alloy we studied is amalgam. It is an alloy of mercury, and ferrous and non-ferrous alloys are there. Finally, corrosion, that means it is the gradual destruction of the metal by means of the chemical or electrochemical attack by the environment. Okay. See here, rusting. What is rusting? It is a very important question. Rusting. Rusting means it is a hydrated ferric oxide formed on the surface of the iron or iron containing compounds, that is called rusting. Chemically, it is the hydrated ferric oxide, Fe2O3xH2. Okay. See, there are 2 types of corrosion, one is wet and other is what? It is a process happen in the absence of moisture, and the wet means it is in the presence of moisture. Okay. So, finally, how do you prevent corrosion? And number 1 is alloying. By making alloys, you can prevent the corrosion of the metals, and second is surface coating. There are 4 methods. Number 1 is what? Galvanization. That means the coating of zinc over iron is called galvanization, and the second one is electroplating. That means you can coat one metal over other metal using electricity, that is called electroplating. And the third one is anodizing. That means metal surface can be make it into durable, decorative and corrosion resistant form. And finally, cathodic protection. Here a sacrificial metal that can be used to protect the metal. The protected metal is the cathode that can be protected by means of this sacrificial metal. So, these are all about your chapter. Thank you very much.